Hello. If you are one of us, thank you. So, in the nodal analysis, we got three simultaneous equations which had three variables. We were supposed to find the values. So, to find it, we see that we had to use Cramer's rule. So, what is Cramer's rule? Cramer's rule is a rule that helps us figure out the values of unknowns using matrix. This is a square matrix. You only apply to square matrix. So to start, we say that x1 is equals to dx1 d divided by d, x2 is equals to dx2 divided by d, x3 is equals to dx3 divided by d. So to start by, let's see, for example, we have a matrix, three simultaneous equations here. We have negative, we have 1. Okay, you can see these equations over here, the three of them. So in matrix forms, they are written like this. So it is 1, -5, the first row, 1, -5, -6. The second row, you have -5, 19, -2. So it is for x1, x2, x3, x1, x2, and x3. Then we have -1, -1, and 2. In the second part, we have a column that is x1, x2, and x3. So to move from this matrix form to this other, to get the simultaneous equation, you are supposed to multiply by the row by column. So you start by this row, then multiply by the column. So if you are to get, you'll get back to a simultaneous equation. Then we have the third, or the right side of the equation, having 5, 0, and 0. So what is this D? So to figure out, let's first know how we find determinants of 3 by 3 matrix. So to find the determinant of 3 by 3 matrix, we use Sarah's rule, or Sarah's, the way you pronounce it. So Sarah's rule states that to find the determinant, you have to, as you can see, we have A1, A2, A3, A1, 1, A2, A1, 2, A1, 3. Then you have A21, A22. So the 1 at this point stands for the row. Then the second one, it is a subscript, stands for the column. So we are in column 1, row 1, column 1. Then this second A, which has subscript to 1, it is because it is in row 2, column 1. We have, let's say, this A32, we have row 3, column 2. So to figure out the determinant of this thing, you have to move the first row and rewrite it at the bottom of the third row. So we have this, it is moved, as you can see, the arrow is pointing to where the first row is, from the first row to the fourth row. Then the second row is moved lower to form this fifth row. So to find the determinant, you have to find the, what we call these are diagonals. So you'll find the diagonals. You can see diagonals from A1, A11, as the blue lines are. You can see this A11, A22, and A33. These are forming our first diagonal, that is A. We are labeling it A. The second diagonal is A21, A2, A32, and A13, as you can see. Then the third diagonal is A31, A12, and A23. So we have A, B, and C. This one we can call them major diagonals because they are the first one. They are coming from the top left corner to the bottom right corner, so of our square matrix, that is. So when we do this, we to find the determinant, you are taking, so we have these other diagonals which are moving upwards. You can see these ones, the black ones. So what do we do now? to find the determinant, you take A plus B plus C, which we call our major diagonals, minus the summation of the minor diagonals, that is D, E, and F. So we have A, whereby our A is the product of our diagonal. So we have A, for instance, it's A11 multiplied by A22 multiplied by A33. Then B, we have A21 multiplied by multiplied by A21, A32 multiplied by A3. So we can see over here. Then we have our D is here. We have it, this one, this row, as you can see, it's coming from this point. Oh no, our D is this one, from this point to this point. So we're having A31 multiplied by A22 multiplied by A13. That's our D. So you get the major diagonals, those ones running upwards, then minus the minor diagonals running downwards. I think we are together up to that point. So let's figure out what these dx1, d, dx2, d, and dx3 are. So let's continue from there. We have these equations now. They are simultaneous equations, so there are three of them. So to find the x1, x2, and x3, here we have to first of all find the matrix of the determinant of the square matrix. We will call it our D. So our D, we will find the determinant of this matrix, the square matrix over here. So it will be, as we saw in Saro's rule, you can see it is 3, -2, 1, -2, -1. I'm reading column wise, row wise. So we have -4, 7, -1, 2, -3, and 1. Then we move the first row to be the fourth row, then the fifth row to be the sixth one, the fifth one. So we have this row, it's moved to this point, and this one moved to this point, as you can see. So to do that, after doing that, what you do next, you come and find your A, B, C, D, and F. So our A, we got it as 3, as in we said it's our diagonal A. So it's 3 multiplied by 7 multiplied by 1, then which is equals to 21. So then, and these are just an example how we find A, B, C, and D. So our A, we have that one, this one over here, which is this one, this from this point, 3, 7, and 1. Then we have our D, it is the minor diagonal. We call them minor diagonal. So we have 2 times 7 times -1, as you can see here, which is giving us -14. So we come back here. So to find our major diagonals, we have to add A plus B plus C minus D plus E plus F, each other major diagonals minus the minor ones. So we have here our A, B, C, and D, E, F. So we have them here. So we got 21 as our A, -12 as our B, and 4 as our C. Then minus -14, as you saw, we got 14 here as our D. Then plus E plus F. So we are getting -14 plus 9 plus 8, which is equals to 13 minus. So this one is giving us 13. Then minus this one, which is giving us 10. So it is 13 minus 10, which is giving us 13 minus 3, which is giving us 10. So to find dx1, we had this matrix over here, this one. This is what we had at first. As you can see, there is nothing changed. So to find dx1, you find the column of x1. So x1, it is here. If we were to recall our equations, or to make them go back to the simultaneous equation, we'll find out that these 3, 4, and 2 are the coefficients of x1. So meaning our x1 coefficients are 3, -4, and 1. So you take the coefficient of that variable. For instance, our variable here is x1, so you replace with this column on your right. So you replace the column of your variable or your unknown with the column at your left, on your right hand side of the equation. So you get, we took 12, 0, and 0 and placed them to the first row, the first column. That's why I have 12, 0, 0 here. Then the other ones stay intact. So what do we do now? It is finding the determinant of this matrix that we have formed here. It is a 3 by 3 matrix. Also, it is a square matrix, so we can find using Sarah's rule or Saru's rule. So to find it, we start at this point, whereby we had to move the first row to the bottom. You can see over here. Then the second row followed it. So to make things simple, we did multiply. As you can recall, we found our a, b, c, and d. So our a, b, c, a plus b plus c plus d, that is our a being 12 times 7 times 1, b being 0 minus 3 times, this giving us 0, then this giving us 0. So we have 12 times 7, that is 84. So that's why you have 84. Then we have the other row giving us, this first one is 0, the second one is it is 12 times -3, you're getting -36. And that is why you have now our 0 multiplied by -2, then multiplied by 1. So we had this one, it was +36 because it is 12 times -3 times -1. So that is why we have 84 minus 36, because it was minus +36. That is why you have this 48. Then dx2, you had to come here again, this point, then remove this column and replace it with the column on your right, then finding this determinant. That is where we find our dx2. So finding this determinant, we got -24 minus -48. Our answer was 14, or was 24, you can see. Then lastly, sorry for the interruption, lastly we have this point over here, dx3. So dx3, we replace the last column over there, our last column with our column on the right, and goes this equation over here, this matrix. So finding the determinant using Saru's rule, we got 144 minus 168, that is -24. So by CRAMER'S rule, we say dx1, to find x1, you had to take dx1 minus dx1 divided by d, then which is equals to 48 as we found it, then divided by 10, we found 10 as our d, then which is equals to 4.8. Our x2 will be dx2, which was 24, then d divided by d, which was our 10, which is giving 2.4, and x3 is equals to dx3 divided by d, which was giving us negative 24, this one here, then divided by 10, which was our D, which is getting 2.4, negative 2.4. So that's how we found our values in the nodal analysis. Where you had not understood, now I think you are good to go. Thank you for watching. Keep watching and you'll get to understand much more. Thank you. Welcome back. Like, subscribe and comment.